Hey everybody. Thanks for coming in, coming back, sitting down, and hopefully getting some SLS learnings out of your next 20 minutes. We talk a lot about our SLA products and our SLS products, and today I'm really excited to give us a little bit of insight into what's new in SLS. I'm Matt, I'm a product manager on SLS, and after me we'll have Matthias again from Brose with his promised second half of his presentation, which I think you guys will enjoy very much. So today we're going to do a quick recap on what's new with Views, but this is a user summit. I think you guys, more than getting the updates, you really want to walk away with something interesting that you can learn more about your ecosystem. So we're going to get into some productivity tips and tricks, and then we'll finish up with a user highlight from Brose. So at some point, we will get to, there we go. So if you know our products, which I think all of you guys do, you know that they're very easy to use, they're very reliable, and they're very versatile. And this has earned us many, many happy customers across SLS as well. There's a reason why more than 50% of all SLS users choose the Fuse ecosystem. For one thing, it's very easy to use with a complete end-to-end ecosystem that takes you all the way from creating your parts in CAD all the way to getting a finished, clean part with automation in between and a very simple, easy-to-use ecosystem. We're also a very versatile ecosystem with a bunch of different industrial materials for pretty much any application you might need, whether that's soft or stiff or flexible. And of course, the ecosystem is also very reliable, which has earned us many happy customers who trust Fuse for the toughest jobs, for innovating, for driving that innovation as fast as possible, and for all kinds of new types of applications that we just keep building on every year. And that is powered by the Fuse 1 Plus. I'm a huge fan of this printer, obviously. It's a industrial workhorse. You can get your same-day SLS parts. It's incredibly fast. And you can get a very large set of materials, all of which work very well for different applications. But productivity isn't just about printing. It's also about post-processing. So the Fuse Blast, which we announced last year, really takes you to that next level of productivity with automated, completely hands-off part cleaning. We now also have a polishing add-on. So if you haven't tried one of the samples, we've got a bunch over in the other room. But you can get really nice, smooth SLS parts that don't necessarily look SLS printed. Very cool. As well as really nice ergonomic functions for manual assisted or manual handheld cleaning for all kinds of parts. And as Nick said before, all of this innovation is driven by you guys, our users, who have been telling us that you need accessible SLS, you need performant SLS, you need productive SLS. And we were going into 2024 trying to think of what is it that you guys need. And you told us that you need even more of all three of those things. And I'm happy to say that this year we delivered. So we had the biggest SLS set of products that we launched this year ever, and we're continuing on an awesome path forward. Just to highlight a couple of these things that I think are really exciting, we have even higher throughput through awesome algorithm and software improvements. Now you can get 14 hours for 95% of all full nylon 12 builds, or 8 hours for an average customer print, to really get you that same-day part throughput. And that means that our customers have been able to get massive productivity gains. So now they've got Fuses printing end-use parts in industrial situations. For one example, we have this a real customer printer that is going almost half a ton of printed parts per year over 349 jobs, so almost one print per day. And we're getting more and more customers getting up to this level of productivity and really pushing the limits of Fuse. So we've also really focused on production economics as well as production throughput. So with bulk powder pricing, your part costs can scale with your usage to make sure that you're getting the most out of your Fuse as you continue to ramp up. And of course, we've continued to give you even more applications. For example, with nylon 12 white, for the first time on an SLS printer under $100,000, you can get white parts that you can then color and dye and polish with the Fuse Blast polishing system with a really easy off-the-shelf setup. So that's just a little bit of all of the different products that we've announced this year. There's a lot more, but as promised, I'm not going to just give you the pitch on the ecosystem. You guys know why it's awesome. But I want to give you guys a little bit something to walk away from this with. So we're going to pivot a little bit and talk about mastering productivity on the fuse. So how do you get to be those customers printing half a ton of parts per year, right? We're going to talk about packing and packing density, a quick recap. We're going to then talk about refresh rate, and we're going to wrap it up with how do you think about labor across the fuse ecosystem. So real quick, you guys know this already, but on SLS, you get your sintered parts, and that's supported by the supporting powder, which is why you don't need supports on SLS. They're all built up within the cake. And if you take that cross-sectional view through the build, this is what it looks like. You have sintered parts, and you have the supporting powder. Now, packing density is the proportion of that fused sintered powder in your build to the unsintered and supporting powder. So for example, in the image on the left there, you've got your parts floating in the powder. If you were to calculate, it would come out to about 15% of all the powder is sintered, and that is a 15% packing density, right? And the really cool thing about SLS, as you guys know, is that you can reuse that unsintered supporting powder, and that's defined by your refresh rate, which is the proportion of that reused powder to the new powder that you add into the next build, right? So for every build, I go to my sift, I tell it 30% refresh rate, 30% new powder, 70% used, and then I start my next print, right? Just to plug again, very easy to use ecosystem. Sift does this for you. You just push a button, it handles all of that for you. There's a reused and a new powder hopper. It's all very good. But if you've been paying attention to the last 5 minutes, I'm going to do a little bit of a pop quiz here. So we're going to show you a couple different builds and see if you guys can guess which one of these, given packing density and part cost, you think would give me the lowest part cost. So which one? Which one do you think? Is it A? Let's get a show of hands. Is it A? Nobody. B, C, or D? D? Okay, yeah, we got a lot of hands up for D. Okay, we got a lot of smart people in the audience here because yes, in fact, the lowest part cost is number D, or letter D. And that's because we've got a really high packing density. We got a lot of parts in there, making the most out of our 3D space. But if you were to look at B, you might see that that is very expensive, right? What is different about B? I thought that I can reuse all my powder. This is where the interplay of packing density and refresh rate comes in. So if you have an average build that you keep printing and it's at 15% packing density, you actually can't reuse all that powder for the next build because you can only get 70% used, right? So you see there's a mismatch between that used powder that I'm producing and the used powder that I can reuse. So a quick thing to take away from this is match your packing density to your refresh rate as much as possible. Get the most out of that build space, get the most out of that build volume, and then you're going to get the best part economics. Now, that's pretty easy to say and not always very easy to do in every case. In fact, I just pulled this from our some user data, and it turns out most builds are not hitting 30%. You're just throwing parts in there. You want them next day. I totally get it. So if you're in a really production circumstance, then yes, you can iterate and optimize. But what you can also pull away from this is when we're talking about labor and costs, something you shouldn't do is spend time recovering more powder than you can reuse. Now, before the fuse blast, people felt they really had to clean in the sift a lot. Now that we have that, you can throw your parts, they'll get cleaned. But we still have a lot of people who are wondering, how much powder do I need to recover? The answer is only as much as you need to actually reuse. Now that's, again, really easy to say, but in practice, this is kind of the decision that people have to do on a day-to-day basis when they're cleaning off their parts in sift. And the question is, what is enough recovery? So again, we're going to do a little bit of an exercise together, some shows of hands. The exercise here is we're going to track this build. On the top left, you've got 0% recovered. It's still in the cake in sift. And the bottom right, you've got fully cleaned after a fuse blast session. And we're going to step through different stages of clean and try and figure out which one is 70% recovered. If it's A, B, C, D, or E, none of the above, just doing it visually. So can I get a show of hands? Who thinks that D is the 70% recovered? Okay, no one really. Okay, one, there we go, one person. Okay, how about C? Does anyone think C is 70%? Okay, we got a couple, 3 hands. How about B? Is B 70? Okay, we got 3 hands, 4 hands, great. How about A? Is A 70% recovered? Okay, most hands for A. How about E? None of the above. Ish too. Okay, we're really evenly split here. We got a bunch of experts here, and I think this kind of shows that it's not super straightforward. The answer is actually E, none of the above. These are all more than 70% recovered already. After 5 minutes, you've already gotten back more than 70% of the powder that you need for the next build. And I wasn't just doing this to point out that you guys don't necessarily know how clean it is. Experts spend too much time recovering powder. I actually went out and, as a good product person, did some surveys, in this case of internal formling experts across the globe, to try and figure out when they would stop cleaning. And you've got there a step 1, 2, 3, or 4. And as it turns out, only 4% stopped too early, and more than 50% of respondents would have lost money based on the amount of time they were taking recovering powder. So the first cutoff that you have there is the refresh rate cutoff, which is when you'll actually be able to reuse all that powder. And the second is the labor cutoff. At that point, you've already recovered more than 93% of all your powder, and every extra minute you're spending is actually just labor. I mean, I know it feels good, it might be therapeutic, but at that point, if you're thinking about it in terms of cost per part, that's actually where you should probably stop. So if we can pull anything away from here, it is that, number one, yes, match your refresh rate to your packing density as much as you can for best economics in a production circumstance. Keep iterating, increasing that packing. And number two is you're spending too much time on sift. Most of the time, you're probably spending too much time trying to get powder back. Take the parts out, knock them off, and you're probably already at 70% in the first 5 to 10 minutes. And if you have the fuse blast, it makes your life a lot easier as well. So with that, I hope you guys have learned something. I hope this was really educational. And now I'm going to hand it off to Matthias, who's going to take you through more real-life user experience of getting the most out of a fuse. So I'll pass that along. There you go.
Very good job. Yeah, welcome back, actually. And thank you very much again for having me. In case you missed the earlier introduction, I don't want to make it too painful. So my name is Matthias Schulz. I do work for Brose. Brose is a global automotive and e-bike supplier. One thing to add to what Matt was just saying, right? And when we talk about sifting, right? And I didn't prepare that in the presentation here, but when you talk about sifting, one option that really helps us is you can play with the temperature for your cookie, right? And then when your powder cookie comes out, right, you can, when you play with those temperatures, you will find out it can break a little bit easier loose than otherwise. So yeah, make sure you use that feature. That's a really good option, at least for us. It works. It really depends on a little bit on pack density, right? If you have to go up or down, so you really have to play with it. But if you have repetitive prints, that really helps. Okay, let's talk about Brose and how we are set up, why we choose Formlabs, why it is important for us to work and continue our work with Formlabs. So first of all, we have additive technology split up in 2 locations for Brose, right? There's a headquarters in Germany, which does also R&D work, right? They also hold some patterns and have some PhD folks available to actually push the envelope, right? And then we created another location within my department in North America. We're located in Urban Hills, Michigan, right? And from there, the initial idea was to create a chop shop. That prints single parts and prototype parts, right? But in a matter of fact, we realized pretty quick that the technology gives us way more than just those single part prints. So yeah, we found a way to get actually into serial production. But going to that point, why we did choose Formlabs and why it is so important for us, right? We looked for a partner that is, first of all, US-based, right? Because we needed support quick. Again, I didn't want to build an R&D center. I needed somebody in case the printer breaks as an issue. And especially when you talk serial production, and Formlabs acted to that point very often. We had turnaround times from 24 hours of them supporting us on site, et cetera. So this is something that was really crucial for us to make that happen. On the other hand, we looked at items that are low maintenance, right? We didn't really want to invest into the high labor amount, so that was a big point for us. And if you look at the fuse in particular, if you change over and if you have 2 build chambers, which is key, right, then you can change overs within minutes, right? Yeah. yeah, that was another big point, and then of course a turnkey solution, right? You have with Preform software that kind of does it for you if you want to, right? You can now go into more details with the PSE and etc., right? That Formlabs offers, like I was just talking about with the powder cookie, right? But if you don't want to, you literally can drag a part in there and yeah, get a good result, right? Yeah, now talking about how we got into serial production, right? So when we talk prototype for automotive, and especially in our area for seats, right? Prototype is not just your 50 parts, right? Usually we talk somewhat between 100, 500, 800 parts for prototype builds, right? So for a lot of people, this is already like a small serial production. For us, this is like everyday business, right? Yeah, so on this side over here, you see a gear housing actually that we printed, right? In this case, several hundred were needed. We definitely, when we go into higher volumes, always choose SLS for a simple reason, because again, I mentioned labor, right? We try to do it lean and efficient as possible. I'm not a big fan of support structure, so that really like helps us over here to make the decision pretty simple, right? On the other side, you see where the two technologies actually meet, right? Where you can use SLA and SLS in conjunction. So this is actually a comfort mat, right? The comfort mat later gets installed into your seat adjuster. It's basically where you sit on to give this nice, comfy feeling, right? For the SLAs, we do use the Form 3s, Form 4s, right? We have several dozens of those actually throughout the Brose group. And I can tell this over here, and I discussed this earlier with Formlabs. I'm not getting paid for this, by the way, right? Yeah, but we had several hundreds of prints already on the Form 4, and we had literally one failed print. So this thing is so reliable, it's almost unbelievable. So yeah, no matter that they, or no wonder that they made it on the Times Magazine here within 6 months, right? Yeah. Now let's talk into the transition from prototype into serial production. I think the center picture that you can see over here says it all, right? This is really like the counter and mating equipment that you need to have, in my opinion, right, in order to make this transition. This is a blue light scan that you can see over here. So when we do prototypes, very often we do reverse engineering, right? So you have a physical part, you make a modification to the part, you scan that part in, and you use that blue light scan or structural light scan, right, to reintroduce the part into the 3D printer. You get a solid 3D object that you can directly upload into Preform, no issues. So this is also the key technology to transfer over into serial production, because now you come into capability studies. You need to hold different quality requirements, right? This is really key, right? So on the bottom picture, actually, you can see a pulley that we 3D printed, several tens of thousands of parts that we used for end-use customers in current vehicles on the street, right? When we talk serial production at the moment, right, we talk gap printing. What does gap printing mean? It's basically you have an existing tool and there's a design change on that existing tool, and there is a certain grace period until you get a new tool, right? This can, in serial production, vary between 12 and 24 weeks, no problem, right? So this time transition we refer to as gap, right? And that gap printing actually is what we use when we 3D print those parts that actually needed in between, right? So serial production for us at this point is not from SOP to EOP, right? It's really like some niche in between, right? But this niche is really what pushes the envelope further to get into serial production here. So yeah, this was a part that you have seen earlier. So this goes into the BMW X7. We print several hundreds of thousands of those parts actually. Yeah, that being said, now I wanted to get a little bit more into like the quick wins and also the difficulties that we had, right? I think we all share those. It doesn't really matter in which industry you are, right? Biggest one for me was supply chain management. When I created this presentation, I really thought about what can I find as a different acronym for supply chain management, because since COVID, it really ticks me off when I read it, right? So yeah, I think you all had similar struggles, right? Get material, etc., right? 3D printing, I really do not worry about it because I just hand that over to Formlabs. We never had an issue of getting material. How they made it, I have no idea, but it worked. So yeah, definitely something that you don't have to consider when you work with Formlabs. It was a big win for me, right? Oddly enough, and that is one of the most questions that I'm getting asked for serial production, is the part setup. Like, Matthias, how do you and your team work to set up a part for serial production? To be honest, this exact same way like you do for a prototype part, for a single part. The same effort you put in there, you have to put into for that serial production part. And then, to be quite frank, it's a rinse and repeat. You just press that same button on the printer because you want to stay consistent anyways. So you're not fudging around with the program anymore after you're set up. So this is really like I said, one of the most asked questions, but I think it's a low-hanging fruit, to be honest. Yeah, sorry. I think I can answer those later. I'm sorry. Yeah. For maintenance, right? Yeah, I mentioned it earlier already. For us, the transition time in between printing a part and then going into the post-processing process has to be as short as possible, right? So having a second build chamber, taking that part out and then cleaning the printer is really like a 5-minute topic, right? So you vacuum the printer out and then you install your second build chamber and you press the button again and the printer goes while you can work your sifter, right? To not have downtime. Now let's get into the meat and potatoes here, right? Obstacles, right? Quality control, of course, a big change, right? Now you have to, like I mentioned earlier, you have to make capability studies. You have to make in-process checks, like we installed envelope gauges where we press through a certain amount of parts just to see if they still hold the dimensions, right? You have to make checks that your tumbler doesn't break the parts when they interlock with each other, etc., right? And here another good point, it was mentioned earlier, make sure you report problems back to Formlabs. I mentioned it earlier to Matt. I always feel like super important and like the highlight because the other day I addressed to Formlabs is like, hey, I really need a cage where I can print those parts in. And then 2 weeks later, it was like, hey, Matthias, you got the cage. It was already in the makes. It wasn't for me, but right, made me really feel good. So yeah, address those issues. This is really important, right? Then traceability is the next item. When we print prototypes, usually you print those several hundred parts or 50 parts or whatever you have, right? And then you set them aside, right? For serial production, now they actually go for us in a sellable vehicle, right? A seat structure is something that really saves lives out there, right? You put a child seat in there, you put a kid in there, right? This is really something you don't want to mess with, right? So when it comes to traceability, and it kind of falls into the quality control too, now we have to have traceability from the batch that we printed down to the printer log file. So therefore, we created labels that follow those parts around, right? Pretty neat too, right? You will see that in Preform too. You can add labels to the printers as well if you want to, or to the individual parts if you want to, right? But this is something crucial that you don't mix up batches anymore, right? For prototype parts, very often we print 4 or 5 sets of the same parts, and then we throw them all together in the tumbler and let the tumbler run just to save a little bit on blasting media, etc. You can't do this with serial production anymore. You have to have the traceability, right? So make sure you separate those parts. Then part handling is another good topic, right? I'm not sure how it was for you, but before we started with serial production, I called Formlabs, and there was this nice tiny FedEx box that showed up at our front door, and yeah, the FedEx driver was super happy to deliver that. And now we're getting pallets of material. So yeah, you better be prepared for that one too, right? Also, your post-processing probably looks a little bit different, right? Now there's a media blaster that consumes a little bit more media than you planned before, so also that comes on pallets now, so yeah, make sure you have that. Then the last point, and for me personally also the most important point, is culture change, right? So in order to get into serial production printing, especially with an OEM, big name like BMW, right? It took a lot of convincing, right? We don't have to lie to each other, right? Everybody still looks into injection molding, right? It took also a lot of education, right? And very often it starts within your companies, right? We have to make sure that we educate within our companies. We have to make sure that we keep educating our customers if we have to. And furthermore, and this is what I wanted to have you, when you go out there today, ask yourself what you can do to support the education and the culture change. When you look at it right now and you find a university that gives you a legit bachelor's, master's, or even a PhD degree in additive technology, lucky you find a needle in the haystack, right? This is really not out there right now. We all need your help to make this work. This could be as simple as go out there and support a robotics class, right? If you have an old printer that you probably don't have a need for anymore, or you have an FDM printer and you can hand that to a high school, to a university, this makes a big difference, right? So try to push the envelope this way to help all of us, right? That really makes a difference. Yeah, as earlier asked, right? I'm very happy to give some answers and some questions later on, right? So catch me when I'm leaving here, right? Scan the QR code so we can connect if you guys want to, right? And yeah, thank you very much. Appreciate it.